Task number 1. Here we're going to optimize the volume of a cylinder where the cylinder should have a radius and a height which added together is equals to 6. And then we can get a thin cylinder but with a lot of height. Here maybe the radius is 1 and the height is 5 maybe. Here it is, maybe the radius is 4 and the height is 2. Here maybe the radius and height is the same, right? But the sum of these should be 6. So there's a lot of ways of doing this, and the question is, how should we do this to maximize the volume of the cylinder? And what we do then, we start with a formula for what we're going to find with this a cylinder, P times R squared times H. And then we have to find, we have two sides here, R and H, and we have to find this expressed with X. And we know that the radius we call X. And then we need to find the height as an expression of X. But we know that R plus H is equals to 6, right? And we have called R for X, so X plus H is equals to 6. So we see I now isolate H and I get 6 minus X. Yeah. So H is 6 minus X. And then I write this formula all over again. So I have pi times R squared, X, R is X, times the height, which is 6 minus X. And then I just multiply into the bracket here and I get 6px squared. When I multiply this with 6, then I multiply here, I get minus px to the power of 3, like this. So here we have the volume as a function of X. So that is exercise 1. And then we should determine the largest volume of the cylinder. And what is the radius and height then? And there's a lot of ways of doing this. But the thing is, if you want to find the largest volume, we have to find the maximum volume. So we have to find a maximum point of this function here. And there are a lot of ways of finding a maximum point to a function. The easiest way is just to draw the graph on GeoGebra and then find the maximum point. Sorry, there we go. That is of course the easiest thing. Just draw the graph on GeoGebra and find the maximum point. Or we can use cos, I will show that, or we can do it by pen and paper. And if you want to find the maximum point with pen and paper, we have to put the derivative equals to 0, right, like that. Let's do it on GeoGebra first. Here we just write in a function which looks like this, and just Alt P, and we get pi here, x squared minus pi times x to the power of 3. Right. That was the function, and I forgot colon here, like that. So here's the function, and we just want to find the maximum point of this function. You see here we have a maximum point, and we do it graphically. We just press here, extremalpunkt, press here, and we get x is equals to 4. So an x is the radius, right? So when you do this kind of exercises, you should stop for a moment and think, what is x and what is y? X is the radius and y is the volume, right? So we see that we have a radius 1, we get a small volume. If x is 2, we get a bigger volume. And the best thing is to take x equals to 4. The radius equals to 4. Then we see the volume is just over 100, 100.53. And of course, if let's get over here and get the answer here. The largest volume is then 100.53, wasn't it? Like that. Yes, that was the largest volume, and that happens when the radius x, which is r, is 4, and then of course the height here. Remember that these two together should be 6, so height is then 2. This is the answer on exercise 2, found graphically. And now should you determine the largest volume on cost, then you have to find the maximum point by cost. We could use this, for example, extremalpunkt, call it V, like that. And we get two answers. And of course, this is not the maximum value. This is the maximum value, but we should confirm that this is the maximum value. And then we just check the mood when x is equals to 4, and we get a negative answer, which means that the graph is angry. So this is actually a maximum point. So I get this point here, and here I just make sure it's a maximum point. And this maximum point tells me that the radius has to be 4, and this is the volume. This is 100.53, 32 times 3.14. But here we get the exact value. So when we do the cos, we get the exact value here. So that's the exact volume, 32 pi. And so then I've solved it in cos. And then we should do it by hand as well. I may just show this quickly here. Determine the maximum value with pen and paper. Then we have to, first of all, find the derivative of this function. And then I keep the constant 6 pi. And then I differentiate x to the power of 2, which is 2x. Then I keep the constant pi and differentiate x to the power of 3, which is 3x squared. And I can write this as 12 pi x minus 3 pi x squared. And then, of course, I have to put the derivative equals to 0. Like this. This is a second degree equation. We have x squared. We could use the ABC formula, but we can also just factorize here. We have a lot in common. We have the number 3, of course, in common here. And I have pi in common and 1x in common. So then all of this is outside except for the number 4. And then minus, this is outside, one of the x's is outside. So I get this. Then I have a product which is equal to 0. So either this is 0, then we see that x has to be 0, or x has to be equals to 4. So we get two solutions. So we have two stationary points, this, or this. Then we have to draw the sign line of the derivative. Then we need to factorize the derivative, which we have done here. Here we actually have 1, 2, 3, 4 factors. So I prefer to do like this. Put up the first factor, the second factor, the third factor, and the fourth factor. And the first factor is 3. If you multiply by 3, that's positive. If you multiply by pi, that's also positive. X is 0 and x is 0, negative here, positive here. This is 0 when x is 4. And remember, if the normally it's always first minus, then plus. But here we see that the term with x is negative, so it's the opposite way, it's first positive and then negative. And then I know the sign of the product of these 4, which is the derivative. 1 minus is minus, 0 is 0, plus here 0, 1 minus is minus. So we see that the volume first, v of x is first decreasing, then increasing, and then decreasing. So this is a minimum point, and this is a maximum point. It's the maximum points I want to find. So now I know that 4 gives a maximum point. So we have a max when x is 4, and then we just put this into the function to find the y coordinate. And where is the function? It's here. So I get 6p times 4 squared minus p times 4 to the power of 3. And this will be 16. This is 16 times 6, that is 96 pi. And 4 to the power of 3 is 64 pi. So I get the answer, which I just got on cos. The maximum value is 32 pi. So that was exercise 1 in the booklet with optimizations tasks.